of information, okay? The first thing you need to know is the first term, which can change, but we'll talk about that a little bit later. But we need to know the first term, we need to know the common ratio, and we need to know how many numbers we're adding up, okay? So let's look at this, looking at numbers 1 and 2. On your quiz, which is next Wednesday, how will you know that this is geometric and not arithmetic?
Because there's an exponent.
Exponent, and that's something you all need to write down, okay? Because on the quiz, it won't say arithmetic. But if you see an exponent, it won't, on the quiz, it doesn't state that it's arithmetic or geometric. But if it has an exponent, that means that it is geometric. And because it's geometric, we're going to use the formula that we just talked about. All right, so looking at the general rule, this first number in front of the parentheses, this is T1. This is your common ratio. And this is my end term. So I'm going to use this formula. So the sum of these 5 numbers is going to equal T1. Thank you. Okay. T1, multiply that by 1 minus R to the power of N over 1 minus R. All right, go ahead and type that in your calculator, just like that. Yep. Well, actually, I might need this one here. You can use this. I have to check the answers. Anybody else need a calculator? Anybody see calculator behind you? That's an extra one? Yeah. Is you the one? All right, pass that back. Any other calculators around here? There's an extra over here. Did you need one over there? Anybody else need one? Okay.
How do I type this in?
So you're gonna hit the parentheses and then hit the fraction button. Yeah. And then just type it in just like that. And if you type it in correctly, you should get 605. That is your geometric sum. Who had that? Anyone need help typing it in? So you're going to hit the parentheses and then hit that fraction bar.
So the 1 equals 1 doesn't mean anything?
But that tells us that we're going to start with the first number, and I'm going to add up the first 5 numbers, going from 1 to 5. The first number plus the second term plus the third term plus the fourth term plus the fifth term. All right, let's look at number 2. For number 2, again, it has an exponent, so I know it's geometric. T1 is the number in front of the parentheses, which is 2. The common ratio is negative 1.5. N is 8. Now, anytime R is negative, you have to put it in parentheses when you type it in the calculator. So you really want to take your time. You only have to do that when R, that says parentheses. I ran out of space, but that's what I was trying to write. So in your calculator, you're going to type in the sum of these 8 numbers is going to equal T1 times, then I have 1 minus negative 1.5 to the power of 8 over 1 minus negative 1.5. And the reason why we have to put it in parentheses is because without it, the calculator is not going to include that negative when it raises it to the power of 8. Remember, anytime you have a number raised to a power, if it's negative, you have to include parentheses. And when you type that in your calculator, we'll just round it to the 10th place. Yes. No, not for the sum formula. So we're using the formula, let me go back 1 second. This formula that I had you all write down yesterday. And this formula, notice it doesn't say n minus 1. It just says n. So you should get approximately negative 19.7. Go ahead, take your time practicing, typing it in. Make sure you're getting the actual number. Our test next week is in between a quiz and a test. That's why it's worth 75 points. And I lost my train of thought. If I remember what I was going to say, I'll come back to it. But it's on Wednesday. Next week on Wednesday. Any questions about numbers 1 or 2? Okay, when we get to number 3, that's where it gets a little tricky. Okay, so we have to tweak our formula just a little bit when we get to number 3. The reason why is because notice the number at the bottom of the sigma is not 1. What this is telling me, these two numbers tell me that I'm going to start with the 5th term, and I'm going to add to that, I'm going to go from the 5th to the 10th term. Well, if you look at those numbers I just wrote, how many numbers did I just write?
6.
I only wrote 6 numbers. So that means in this example, n is 6. Again, that's because this tells me to add the 5th term through the 10th term. So that would be 1, 2, 3, 4, 5, 6 numbers. Since I'm not starting with 1, I don't need to know T1. I need to know T5 because that's the first term that I'm going to add. So we're going to use this rule right here to find T5. So what you see in that green box, that's my rule. So in your calculator, you're going to take 2 times 4 to the power of 5 minus 1. And that's going to tell us T5. Does everybody understand why we have to start with T5 and not T1? Because that's the number at the bottom of the sigma. So that would be 512. So now I'm going to find the sum. Oh, okay. And then what's my common ratio? 4. So now I'm ready to do the formula. So the sum of these 6 numbers. Thank you, Camilla. Oh, I'm right here. Thank you. Thank you so much. I appreciate it. Thank you. Okay. It's going to be the 5th term, which is 512. Multiply that by 1 minus r to the power of 6, because that's how many numbers I'm adding, over 1 minus r. So type that in your calculator just like that. All right, you should get a pretty big number. I got 698,880. Anybody else get that answer? Anybody need help typing it in the calculator? Any questions so far? All right, let's look at this next one here. Number 4. So again, I'm starting with what number? What's the number at the bottom of the sigma? The number at the bottom of the sigma is what? 3. So we need to find T3. So go ahead, pick up your calculators. Type that in. You should get 1.75. And then we know R is 0.5. Now, what is N going to be? Show me with your fingers. What are you going to use for N? 3. So because this is telling us to start with the 3rd number and go up to the 5th number. So that's 3 terms. So N is 3. So using your calculator, we're going to type it in. So we got our T1 or T3 in this example. And we're multiplying that by 1 minus R to the power of 3 over 1 minus R. Go ahead, type that in, and that would be your sum. You are so right. Thank you. That should not be a 6. What should it be?
3.
3. Thank you. Let me fix that right now because we're adding 3 numbers. Okay. Who got that 3.0625? All right, so let's finish it out. Let's go to the back. Now, there are 2 different types of geometric sequences. And notice how here it says the infinity is at the top. What that means is I'm going to start with the first number and I'm going to add up the first number through the infinite number, which could say like, okay, that's impossible to do. But that's actually not true. The only time it's not possible is if you're multiplying by a number greater than 1. So an infinite series has a sum only if the absolute value of your common ratio is less than 1. If the absolute value or the number you're multiplying by is less than 1, then we say that that series is going to converge, which means it's going to eventually plateau. Because if you start with a big number, eventually it's going to plateau and get really close to 0. It'll never actually be 0, but it's going to get closer and closer and closer to 0. That's only if you're multiplying by a number that has an absolute value that's less than 1. If you're multiplying by a number that has an absolute value that is greater than 1, and it's an infinite series, that means it will have no sum. So we're going to look at these 2, and we're going to determine which one has a sum and which one does not. So for part A, do you see how we have an R value that is 3 over 2? Yeah, R equals 3 over 2. Now I'm going to ask you, is 3 over 2 less than 1 or greater than 1? Greater, because 3 over 2 is it was actually 1.5. And 1.5 is greater than 1, which means that this has no sum. This series is going to continue to get bigger. Every number is going to get bigger and bigger and bigger. It's going to keep increasing. It's never going to plateau. It's an exponential function that's just going to keep getting higher and higher and higher. So because of that, it doesn't have a sum. We don't have any formula to look at. When we look at B, though, the R value is 1 over 5. And 1 over 5 is less than 1. So here is the last formula that you have to know for the test. And I also wrote it here. It's at the top. It's kind of small right here, though. This is your last formula. This is only if it's an infinite series. To find the sum of an infinite series, if it actually has a sum, then you would take T1 and divide that by 1 minus R. That's your last formula. So the sum of an infinite series is going to be T1 divided by 1 minus R. So in this example, T1 is what? What's the number in front of the base? -5. And we're going to divide that by 1 minus the common ratio, which is 1/5. Go ahead, type that in your calculator to get your sum. That's your infinite sum. So your calculator could either give it to you as a fraction, or it could be given to you as a decimal. And that would be your answer. But again, you only use that formula if R is less than 1. The absolute value of R has to be less than 1. On the quiz next Wednesday, there's going to be 2 questions. One of them has a sum, one does not. You have to know when you're using a formula and when you simply say no sum. So the answer to A is just no sum. It has no sum. So I want you to look at these 3 and figure out which ones have a sum. If it has a sum, use the sum formula. Here is the sum formula for an infinite series. Sum of an infinite series is T1 over 1 minus R. So looking at number 1, does it have a sum, yes or no? Who says yes? Who says no? What is the R value? 7 over 3. If you take 7 and divide that by 3, is that greater than 1? It is. 7 over 3 is greater than 1, so that means this has no sum. You cannot use this formula for number 1 because 7/3 is greater than 1. If you type 7 divided by 3 in the calculator, you get, what do you get? Oh, wait, I typed that in wrong. You get 2.3. 2.3 is bigger than 1, so that does not have a sum. That's your answer to number 1. What about number 2? Do we have a sum? Yeah. And again, I'm looking at this number. This is the number I'm looking at to determine if it has a sum. 0.4 is less than 1. So this one has a sum. So we can use our formula. T1 is 2/3. R is 0.4. So to find the sum, you're going to take 2/3 and divide that by 1 minus 0.4. So I'm gonna go ahead and lift that up. Go ahead, type that in your calculator just like that. You can write that as a fraction or as a decimal. All right, who got that? 10 over 9. 1.1. Okay. All right, last one here. Let me get some more space to the right. Okay. So negative 2 over 7, that's why we say the absolute value. The absolute value of negative 2 over 7 is 2 over 7. Is 2 over 7 greater than 1 or is 2 over 7 less than 1? Less than 1. If you were to take 2 divided by 7 in your calculator, you get 0.285, et cetera, et cetera, et cetera, which is less than 1. So this one does have a sum. This has a sum because 2 over 7 is less than 1. So this has a sum. All right, so T1 is 8. R is negative 2 over 7. So to find the sum of this infinite series, you're going to take 8 and divide that by 1 minus, and then I'm going to put negative 2 over 7 in parentheses. And that's what you're going to type in your calculator. Oh. We almost done. I know. You did. Okay, so we're going to take 8 and then divide that by 1 minus. And because it's the negative 2 over 7 doesn't have an exponent, it doesn't need to be in parentheses, but to be consistent, I'm going to just keep using my parentheses. The parentheses are important when it has an exponent. So my calculator gave me 56 over 9, which is equivalent to approximately 6.2 repeat. Who had those answers?
So what was the point of putting absolute value?
Because I wanted you all to realize that some people get confused with that, what the absolute value means and all of that.
What does it do? Just flips it?
Yeah.
So why did I say the answer? Like, why is it still negative 2 over 7?
Well, we're using the actual R value that's in the equation, which is negative. So that would be this one. All right, last ones, and then we'll be finished for today. Or finished, period, really. Yeah, this is our last one. All right, so it wants us to find the first 2 terms of this infinite geometric sequence. They told us to sum, and they gave us R. So for infinite geometric sequence, first we need to realize what the formula is. S1, or sum of the infinite series, is equal to T1 divided by 1 minus R. And they gave us this number and this number. And we need to solve for T1. So we know that 10 equals T1 divided by 1 minus 0.2. So 10 equals T1 divided by 0.8. Multiply both sides by 0.8. Go ahead, type that in your calculator to get T1. So 0.8 times 10 is 8. How do you think we're going to find T2? What do you think we're going to do to find T2? What's our common ratio? What's the common ratio they gave us? 0.2, yeah. So to find T2, we would take 8 times the common ratio. If you take 8 times 0.2, then you get that T sub 2 is equal to, I think that's 1.6. Yeah. And it only asks us for the first 2 terms. So it says, find the first 2 terms. All right, last one. I want you to try to work through question part B by yourself. Find T1 and then use your common ratio to find T2.